Every time we determine a graph, equation of a graph, we can actually come up with 4 equations because our amplitude can be plus or minus, right? And we can do sine and cosine graphs because sine and cosine graphs are just horizontal phase shifts of each other, right? Now some people say, well, I just want to do one. Cool. You have to be over-prepared because they can ask you for any of the 4 and say you're like, well, I always like doing this one. Great, so they ask you for a different one. So we are always going to do all 4 equations of every graph. Then it doesn't matter what equation they ask you for. It doesn't matter if they say A has to be greater than 0 and it has to be a cos graph, or A has to be less than 0 and it has to be a sine graph. You're like, no big deal, I can do all 4. So ask me whatever you want. Okay? So we know that our equations, so this is our graph here. We'll go back up there in a second. We know that our equations, I'm just going to write the general form up here, is y equals A sine B x minus C plus D, or, and these are on the bottom of our formula sheet, y equals A cos B x minus C plus D. Right? Our A represents our amplitude, correct? Yep. It could be positive or negative because our amplitude is always positive, but the A value could have a reflection or not. A could be positive or negative. What is the B? Where do we get the B from? The period. We have to find the period of the graph, then we can use it to get the period, which is the B, right? The D is what of the graph? We talked about it yesterday. The midline. So if I find that middle line that cuts the graph in half, I have the D. It will be the same for all 4 graphs, right? The B will be the same for all 4 graphs. The A will be the same, but positive or negative. The only thing that changes between every single graph is a phase shift, right? Because any graph, even if I reflect it, I can just shift it a certain amount and it'll land back on top of what it was, right? Even if I make the maxes and mins, I can shift it and it'll land back to where it was, right? So it's the C's that are going to change every single time, but the A, the B, and the D are found the same every single time. So what we're going to do for all the graphs today is we're going to find the A, the B, and the D, and we're going to leave the C just in brackets for now. Okay? All right. Now, from an equation, the amplitude is the absolute value of A, correct? From a graph, the amplitude is half the vertical distance, or, remember I told you this? We can use this formula, which is the absolute value of max minus min divided by 2. Don't worry on your formula sheet, you need to memorize it. Now, we can try it out. So we can go the absolute value of the max. What's the max? 10 minus the min, negative 10, divided by 2. So it's 20 divided by 2, which is 10. Does that make sense? That half of that vertical distance is 10? Yeah, you go 20 plus another 20. Or sorry, 20, that's a lie. 10 plus another 10 is 20. Half of that is 10. Do we agree? So we could just say the vertical distance is 20 and half of that is 10. So let's go down here and let's start our equations. We're going to have 4 of them. We're going to have y equals positive 10. Do we have to write the positive sign? No, but I'm proving a point. Positive 10 sine. Y equals negative 10 sine. We're lucky that calculators are way more hardy than cell phones. And then y equals, if cell phones were made to the hardiness of a TI-84 calculator, we would not need screen protectors. One point in time in all of my 18 years, we're going to actually have a calculator that breaks, but I've never seen a screen break, and they drop all the time. There you go. Yeah, it's just really, it does explode and the batteries do go everywhere, but it still survives. Okay, so do you see how I didn't actually do anything crazy to get that A value, right? One's positive, one's negative, because the A can be positive or negative. Amplitude has to be positive, but the A value of your equation can be positive or negative. Okay. Now we need the B. Well, we know to get the B, the period, we have to do 2 pi or 360 divided by P. Now we have to decide, is it 2 pi or 360? So I go to my x-axis and I say, they're in pi's, so they're in radians, so it has to be 2 pi divided by P. Now remember, the way you can find the period is you can go from a min to a min, or a max to a max, or you can start at the y-axis and actually calculate how long it takes to get past a min and a max. In this case, my y-axis is the max. So I just have to go from a max to a max. What's this going to be? 0.55 pi, 1.52, 2.53, 3.54. So is 4 pi the period? From a max to a max, is that a period? Yep. Because then after that, what happens? I'm going to get, I think that's really nice. I'm going to get the same thing over and over and over and over and over. Correct? So from a max to a max is a period, a min to a min is a period. You can start at the y-axis and go back till you start repeating yourself again. That's a period. Either way, the period is 4 pi. So I know the period equals 4 pi, but that is not my period because those are not the same word. So how do I get the period? I take 2 pi and I divide it by the period, and I get what for my period?
A half.
A half. Now, is that going to change on any of the equations, or is it just going to be a half?
No, the period is the period.
The period is the period. It does not change. Now, why is it a half? What would the horizontal stretch be? 2. And it went from 2 pi to 4 pi. Does that make sense? Yeah. Right? So, our b is a half. And then I go X, some bracket, and we're not dealing with that till later. We're like, no, thank you, not right now, later. You're the thing that changes. We don't want to deal with you. On a test, you can't. You actually have to deal with it. But right now, we're not. So our A wasn't found any differently no matter what equation we did. Our B wasn't found any differently no matter what equation we did. Our D will not be found differently. It's that midline. So for the midline, what we could do is it's the line that cuts the graph in half. So I could count up my amplitude and count down my amplitude, and where it meets would be my midline, right? So I could count up 10, I could count down 10, and where is it meeting at? 0. I want every single person to draw the midline, because it's going to help us for the C value when we come back. So for sine graphs, you always need the midline. We will always draw the midline. Now, there's also a formula for midline. It's just max plus min divided by 2. Why would it be 2 numbers added divided by 2? To get a middle. Middle, aka average. What do you do when you do the average of 2 tests? You add them and you divide by 2, and it will get you the middle of those, the average of those 2 tests, correct? The midline, another fancy way of saying midline, which we can't use as an actual word for it, but it's just the average. It's the average between the maximum and minimum, is it not? So we could just go -10. Didn't know I was still in red. -10 plus 10, max, whatever. It doesn't really matter. You can put them out of order, but I'll do it in the word formula. 10 plus -10 divided by 2, which is 0 divided by 2, which is 0. It's a midline, so I'm going to write it as y equals 0, just to keep practicing, not forgetting the y equals when they ask for a midline. So for effect, I'm going to write the 0 at the back, but do I really actually have to? No. So is finding the A, the B, and the D hard? No. Now I'm going to tell you where common error happens. You mix up the formulas. So you put the D where the A is and the A where the D is, because you'll minus and plus wrong. But think, the D is the midline, which is the average. I add 2 scores, I divide by 2. That's what I would do with the test, right? Understand why. Don't try and memorize the formulas, understand why. And then B is often wrong, because people put the period there. They'll put a 4 pi there. Do you think that they'll put 4 pi as an option? Yep. They'll put 4 pi as an option. It's totally wrong. You will pick it. But remember that B is not the period. It's the period, which I made up to try and get people to quit doing that. Okay, cool. Next one. Yeah, don't explain period on a diploma. They will not know what you're talking about. If you're like, it's just the period. It's not the period. They'll be like, what is this person teaching? Yeah. What? No. The only one that's on the form, that's not your formula.
Oh, wait, so They have stuff we don't.
That's their formula sheet. It has way lots of stuff, you know, and you have way lots of stuff more than
Ours was like theirs plus.
totally different formula sheet. Sorry? Yep, not right now. All right. We're solidifying how to get the A, the B, and the D. Because if I throw the C in right now, which I've learned from all my teaching, is that I overwhelm you, and then everything falls out. So what we're going to do is we're going to find the A, the B, and the D for all of our graphs. We get that solidified, come back with the C's, and then it's not overwhelming. No. You will find out. Patience, my dear Watson. Patience. The C is going to be different for all four.
Yes, I know.
Okay. Amplitude. What's the amplitude of this one? It's 2 because it's symmetrical about the x-axis, but we're going to prove it anyways. Absolute value of 2 minus negative 2 divided by 2, which is 4 divided by 2, which is 2. Or we could count up and we could say, hey, 2 plus 2 is 4, divided by 2 is 2. Same thing, right? The whole vertical distance divided by 2. So let's go fill in our A's. Y equals positive 2 sine. Y equals negative 2 sine. Y equals positive 2 cos. Y equals negative 2 cos. Then I need the period. Not the period, the period. I do need the period to get me the periods. So let's figure that out. So this one, I could go from max to max, but I would have to go like 0.75, 2.5, subtract them, right, and get my answer. So I could do that. What I can also do is start on the y-axis and see if I can get myself to repeat. So I'm going to try to show you that's another option. So I can go like this. Now I have to go past the max, back to that height. Have I started to repeat yet? Just keep going. Yep, past the min, then back up to here. Then what happens after that? I start to repeat, correct? This is really hard because this I think would go up here to 2.75. So going max to max would not be very productive because they don't even have to full max on it. You could go this way. That full max isn't there, but this full max is. You could go 1.25 plus 0.75 and say, hey, that's 2 pi. You could do that, right? 1.75 or 1.25 plus 0.75 is 2. The fastest way for me is to just go past the max, past the min, and back up to 2. So I know the period is 2. What's the great thing when the period is 2 pi?
You rejoice.
Because b is what? 1. It doesn't change. But we can prove it. B is 2 pi over the period. I'm using 2 pi because the x-axis is in radian. So I do 2 pi divided by 2 pi, which is 1. And the period. So if the period is 2 pi or 360, your b value is 1. You should rejoice. There's no hard work there. Because you have no horizontal stretch. 1, 1, 1, 1. X. 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 Now, how do I get the midline? I'm getting the average of the two scores, right? So, what were they? I don't remember. 2 and negative 2. So I go 2 plus negative 2 divided by 2 is 0 divided by 2, which is 0. And it's a midline, so it's y equals 0. So on a test, I could literally just ask you for the midline, or the period, or the amplitude. You know what I mean? Like I could ask that just from a graph, or I could ask you to find the whole equation, which makes you find them all. So I go plus 0. Now for the c's of the sines for later, I'm going to go draw that midline onto my graph. So it's at y equals 0. And I need the midline for the c values of sine. So I'm going to go like this. the midline must be drawn to get your C values for sine. So I always draw them on it. Okay? Always draw your midline. Okay, next one. We're skipping this one. And if you got ahead, good for you. But we're going to example 3. Why would I pick example 3? Why is it example 3? Yeah, the midline's moved. It's not symmetrical about the x-axis. So, my amplitude is the absolute value of -1 minus -7 divided by 2, which is 6 divided by 2, which is 3. If I counted up 3, 1, 2, 3, and I counted down 3, 1, 2, 3, they meet at the what?
Midline.
The midline. So I can find my midline that way, or I can find my midline by going -1 plus -7 divided by 2, because I'm trying to find the average between them, which is -8 divided by 2, which is -4. So I can use the actual formula to get it, or I can count my amplitude up, amplitude down, and draw myself a line at y equals -4. I like sounding like a leprechaun. Draw myself a line. That was sort of funny. No one's laughing. That's fine. Okay. Thanks for the sacrificial laugh. All right. I also need the period from the period. How do I get the period?
The whole thing.
The whole thing.
It's full.
You guys should write out notes. It's just the full thing. And then that would be your note. Period. Ah, the thing. The stuff. Yes. So I'm going to start on the y-axis. And then I go down. And then I come back up to my max. Because the max to max, how far is that? 4. So the period is 4. Now some people will say to me, I don't know if that's radians or degrees. The giveaway is a degree symbol. Is there a degree symbol on that x-axis? No. So what is it in? Radians. Remember, if the x-axis has no units, those units are radians. If it's a degree, it has to have a degree symbol. So that's the period. When the period doesn't have a pi in it, this is where you guys will mess up and put it as b. Do you see how that could be an easy thing to do? But it's the period, not the period. So I need to get the period. The period is 2 pi divided by the period. So it's going to be, the b is going to be 2 pi divided by 4, which is pi over 2. So now we have lots of info. We can do our A, we can do our B, we can do our D. So we get y equals positive 3. Like I said, you don't have to put the positive, I'm just doing it to prove a point. Sine B, which is pi over 2, x minus 4. Y equals -3 sine pi over 2 x minus 4. Y equals positive 3 cos pi over 2 x minus 4. Y equals -3 cos pi over 2 x minus 4. Right? Gets me all 4 of them. Make sure you put in the period, not the period. Amen. Someone give me an hallelujah.
Hallelujah.
There we are.
You know, John's watching the podcast. Hi, John. Hi.
All right, good talk. I don't remember what graphs I have anymore. Okay. We're going back in time. Oh, wait, here we are. We went back in time. So can we get the A, the B, and the D? We're good at that? Okay. Once again, I have my calculator that is not helpful. Can you guys all type into your calculators, because this one doesn't have a calculator on, it's the other one. Put the other computer that has a calculator on yours. Type in cos x, please. So in your y equals, you are typing cos x. Cos x.
Yeah.
Now, the catch is, whenever we press that equation, we have to pick a mode, and then we have to make our window be that mode, right? You can pick degree, you can pick radian, it doesn't matter, and then zoom straight. So at least try and get a window that's, like, sometimes you'll pick a degree mode, but your window's in radians, and it don't work, right?
Oh,
So that's just your plain old cos x graph, correct?
Yep.
Okay. Let's talk about this. The y-intercept. So for cos graphs, we are looking at that y-intercept. Do you see it?
yeah, one.
What is the cos x y-intercept? What's special about it? It's the maximum. Okay, let's talk about y-intercepts. Let's think about it. So we have a graph that looks like this. Right? And this here is our y-intercept. It's at 0, 1. You let me know what is the only transformation that can get that to get off of there. Vertical stretch, does a vertical stretch get it off of there? Horizontal phase shift is the only thing that can get that baby to move. Let's talk about the rest of it. So a reflection, can it get it to move? A reflection would make it be a minimum. So that's going to be a different scenario. That's going to be the negative cos graph, right? We're talking about positive cos graph, right? Negative cos graph would get you a minimum. We're only talking about positive cos graphs right now, right? So would a vertical stretch get it off of the y-axis? No, it would move it up or down, but it wouldn't get it off that y-axis. We agree? Okay, let's talk about horizontal stretches. Would a horizontal stretch get that off up there? The x is 0. If I multiply x by something, what happens? Still 0, correct? So horizontal stretch doesn't move it. What about a reflection? Does it move it? No, you're multiplying once again by -1. Doesn't move it. What about vertical translation? Does it get it off the y-axis? No. So what's the only thing that can move that baby, that maximum, off the y-axis? Phase shift. So I go to my graphs and I say with the positive cos, I say, is my maximum on the y-axis? Yes. No phase shift. No. Where did it move to? That's the only thing that can move the maximum off. So if you look at this here, I have the c values. So cosine greater than 0, a is greater than 0, so that just means cos positive, right? Y equals cos x. I look for the closest maximum. If that maximum is on the y-axis, I've had no phase shift. If that maximum is off the y-axis, where did I move it to? So let's look at this one. We're only doing positive coses. So do you see I have 4 equations? Cool. I'm only doing these ones right now. Positive coses. Okay? Y-axis. Is my maximum off the y-axis? No. So what type of phase shift did I have? None. So I'm actually done. Could I go plus 0 or minus 0? Sure. Do I need to do that?
Yes.
No. So the positive cos one is actually done. It didn't have to move. Where's my maximum? My maximum is here. It's on the y-axis. So how much did it move off the y-axis? None. So the positive cos would have no c. Let's go to the next one. Okay. Is my maximum on the y-axis? No. If there was no phase shift for a positive cos x graph, this bad boy would be here. Is it there? Is my maximum on the y-axis? No. What did it do? It came from here and it did what? Phase shifted what? 0.75 pi to the right. Because where is it supposed to be located? On the y-axis. Is it? No. It moves 0.75 pi to the right. So I go to my positive cos because that's the only ones we're doing right now. And I have to move it 0.75 right. So what do I do?
Minus 0.75.
Minus 0.75 pi. Okay? Well, you're just making your life harder for the calculator, but you could go 3 pi over 4. Okay. This one, I go look for my maximum, the closest one to the y. Where is it? On the y-axis. So where did it move? Nowhere. So this one is done. If you wanted to, you could go like this. You could add nothing. You could subtract nothing. It's going to do nothing. But if that makes you happy that you have a C, you can do that. Okay, one more. So I did one in between, didn't I?
No.
That was it? Cool. I've lost my brain cells. It's fine. Okay. Now type into your calculator negative cosec.
On a test, could they have, instead of adding like the 0, could they add like 2 pi or like,
Yep.
instead of having 0.75, they could add
Absolutely.
2.75
They
pi?
could, yeah. They'll often ask for the smallest. They could ask for the smallest phase shift, and then you look for the closest one. But they could absolutely make you move 2 shifts over. Yeah. All right. Type in negative cosec. Okay, negative cosec. What's the difference? It does this, but it reflects, correct? So now what's on it?
The minimum.
The minimum. So now this is for the positive y equals cosec. I look for the closest max. What do I do for negative cosec? Look for the closest min. Because the only thing that can move that off is a phase shift. So if I have a choice, I pick cos graphs. Because they're the easiest ones. So let's go back. Hey guys, where are my minimums? Are my minimums on the y-axis? No. I have a minimum here, which should be drawn properly, but it wasn't. I have a minimum here, which is 2 pi, or I have a minimum here, which is 2 pi. Could they use either of them? Could they actually use 4 pi, or not? It would be 2 pi, and then you'd end up at 6. So can we even use further ones down? Yes. Hopefully they don't. Now, I could pick, remember you're going from the y. This is where it should be. It's not there. We agree? So if I want to use this one, I'm moving 2 pi to the what? Right. If I use this one, I'm moving 2 pi to the left. Does either one matter? No, you have to match what they have. If it was a written response, you could give either.
Could we give a fifth equation to both?
If you want to, you can go ahead. So this would be, I'm going to go to the right, so I'm going to go minus 2 pi. If you did plus 2 pi, would you be wrong?
No.
No. It's how far away the minimum is from the y-axis for negative cos. Okay, what about this one? Here's my minimum. Is it on the y-axis? No. What did I do to get there?
Subtract 0.255.
I went 0.25 pi to the left. So how do I put that into my equation?
Add 0.255.
Add 0.25 pi.
X minus 6.
Wait, what?
It's literally the first unit. You put the sign on our X.
If you want to go left, you do plus. If you want to go right, you do minus.
Oh, you want to do right though. So if you want to go right.
Okay, you went to the right.
No,
I thought
you're
negative.
moving from the y-axis, which is where it was. Did I move right?
So you're not moving.
That's what you're eating.
You're moving back around.
It's a quadruple.
You're moving
It's a
it.
quadruple.
It starts on the y-axis. Shh. The negative cosec graph starts on the y-axis. It is not there anymore. Where did it move? Left. Right? Because where does it start? On the y-axis. Where does it move? Left. Could I have given the option x minus 1.755? Here's another minimum. Could I have done that? Could I go x minus 1.755? Yeah. I could move it right. It'll land on it too. So they could use any minimum. If they say the shortest or the smallest transformation, then you would pick what one we picked. I always pick the shortest. But you could also move it 1.75 pi to the right, which would be x minus 1.75 pi. All right. Last one. This one's symmetrical again. So the minimum, if it's here, I would be moving it 2 to the left. If I picked this one, I would say 2 to the right. Remember, you are moving from the y-axis, correct? So I'm going to move it 2 to the left this time because I moved the other one to the right. So I'm going to use this one. So 2 to the left, what do I have to do? X plus 2. Okay, can I get you to do something for me? Go to your calculator, type in sine x in y1, and then in y2, I need the midline. What is the midline on a sine x graph? 0. You go y2 equals 0 and make it thicker. Okay, guys, paying attention. So this is positive sine x. Conversely, this would be negative sine x. Ooh, that's good. And thank you for the lovely line game. Anyways, this would also be y equals 0. Do you see this here where they intersect? Where the graph intersects with the midline? Where is it? On the y-axis. Do we care that it's at 0, 0? No, we care that it's on the y-axis. What's the difference between these two graphs? This one is where it intersects, but I'm going with a positive slope through it, correct? What's this one doing? Going with a negative slope through it. The easiest way to find, so for positive coses, I look for where the max is off the y-axis, right? Negative coses, I look for the closest min off the y-axis, yes? Sine graphs, my hint to you is you're going to look for the closest intersections with the midline. So, I immediately, if I have to do a sine graph, I draw my midline, which I already have, and then I bold the closest intersection points. So here's one of them. Here's the other. Do you see those are my closest intersection points? So in order to get your sine x c value, you need to draw the midline and then the closest intersection points. Okay? Do you see that? Now this is the hardest part, is remembering to do that. After that, you have two c values. So this one is negative pi, I believe. It's really sketchy. Is that negative pi? Yeah.
Yeah.
And this one is pi. So one of my c values is going to be pi to the right, and the other c value is going to be pi to the left. How can I tell which one is negative sine and which one is positive sine?
One of them is negative sine.
One's going up, one's going down.
One's going up, one's going down. Look at this. What's this one doing? Up. What's this one doing? Which one's positive sine? Yeah. So this one going up is positive sine. So for the positive sine x graph, I'm going to say pi to the what? Left. So I go to the positive sine x graph, and I go pi to the left. So I'm going to go plus pi. We agree? If you remember to draw the midline and bold where it intersects, you have a 90% chance of getting your C values right for some. If you do not put the midline in bold, you have a 0% chance. Okay? So for sine graphs, you have to do the midline and then bold the intersections right away. All right. This one here is going downwards. So to get there, I have to go pi to the right, and this is my negative sine x. How do I go pi to the right? I go x minus pi. Okay, this one, I go here and I bold my intersections with the midline. One of them is going to be negative 0.75 pi, so I'm going to be going negative 0.75 pi to the left. And the other one is going to be 0.25 pi to the right. Which one is positive sine, which one is negative sine? What's this one doing? Going down, so this is negative sine x. And this one is going up, so it is positive sine x. So for the negative sine x equation, if we pretend that's actually a horizontal line instead of whatever I drew, it is going to be 0.75 pi to the left for negative sine. So if I want to go 0.75 pi to the left, I have to add 0.75 pi. And then the positive sign, I want to go 0.25 pi to the right, because that's a positive sign, so I have to go minus 0.25 pi. Well, sine, you could pick any of the intersections that have positive slopes. So technically, you could keep going. You could go to the next one and say, I'm going that far. Okay, then this one. Here is my midline. So this is where I intersect with my midline. So this one is one left. When I use this one is one right. How do I know which one's positive sign, which one's negative sign? This one is positive sign because it's going upwards. This one is negative sign x. So for the positive sine x graph, I need to go one left. So it's x plus 1. For the negative sine x graph, I need to go one right. So it's x minus 1. Now, how do I know if I'm right? I just got an equation and I have a graph. It's crazy. Could I not type the equations in and see if I get the graph? And the best way to do that, paying attention, is make your window be their window, right? So I know this is in radians, it has to be radians. I make my low, my x min be -5, my x max be 5, my y max be 4, my y max be -7. Actually -8, right? And then I type it in. And it should look the same because you change your window to be their window. All right? Okay. We're going here. So this one says, the graphed function is represented by the equation in the following forms. So this one wants sine x, where a is positive, right? That's all that means. So they might ask for a sine x graph where a is positive. Or they might ask where a sine x graph where a is negative. Or they might ask for a cos x graph where a is positive. Or, I don't see it on the page. Cos x graph where a is negative. So I want this completed for tomorrow. all 4 of them. All right?
There's an E divided by no, look, Julia's, we can add to 4 questions.
Page 250, number 15 and 16 are really good practice. And most people need to practice these. This is the sin x, they just ask for sin x graphs. And for 16, they just ask for cos x graphs. So you don't have to find all 4. Now some people say, I want to find all 4, but there's no answer key. Do you need an answer key to check all 4 of them? No, you're finding equations that match a graph, correct? You have said graph on page. You just type it in to your calculator and see if it matches, right? So there's 3 graphs for 15 to find the sines, and there's 3 graphs for 16 to find the coses. These are good practice. But tomorrow we're going through this one at the very beginning. Then all we have left is word problems and tangent graphs.